Hi guys, this is the CEO of Haimus Racing, and today I'm going to talk to you about our carbon fiber V8 Plenum for the E92 M3. So what I'm going to do today, I'm going to talk to you about three main things. The first one is design, second one is going to be functionality, and the third one will be structural integrity. What we have here is we have our carbon plenum and the OEM carbon plenum. First thing we did was we wanted a design which is very simple. It's not over the top. The M3 in general has been a car which just refines what BMW does best. That I wanted to convey that into the design language of the plenum. Also, we looked at the M5 CSL, the E60. It had a very simple carbon plenum design, and so we took some inspiration from there. And this is what we came up with. It has a very smooth finish on the top. There is no extra detailing here. It's just simple, minimalistic. On the back, you have the elegant trumpets. You have a very smooth section. A lot of the parts, a lot of the indents have been smoothed out from the OEM one. The throat has been slightly modified. And overall, it's a more or less very OEM-like item. That's what we were going for. Now, the second thing I want to talk about is functionality of the airbox. For those of you that don't know, our airbox on our dyno was able to increase the Newton meters of our car by 25 Newton meters at around 3000 RPM, and it gained 4 wheel horsepower at the top end. That's a huge result for just a plenum, and that was done without any remap. We just took this airbox out on the same day, same conditions, on the same dyno. We put this one on the engine and the car was quicker. So I'm going to talk to you about what we did in order to make that happen. The first thing we did was we smoothed out this part of the intake here. If you look at the stock intake, there is an edge over here. We kind of smoothed it out, and especially on the inside, if you put your hand through, there's not an edge. Same thing goes for this side as well. Here we added a bit of material and we're able to smoothen that out as well over here. Now, a smooth internal part of the intake will simply enhance flow attachment, and this is great for high RPM horsepower. Another thing we did when it comes to functionality is we increased the internal volume by a whole lot. It's close to 15% larger than on the stock plenum. First thing we did, as you see, is the smooth top of the intake. If you look at the stock intake, you have these indentations everywhere. We filled the indentations. We filled the intake over here as well and made a very smooth surface. The increase in volume comes from that. Another thing we did, we increased the side volume. If you look at the OEM intake, you have this about 1 centimeter thick ridge at the bottom here. We made that ridge a little bit smaller. And so on the side of our intake, you don't have such a big ridge. And what that does is it increases the volume of the bottom part of the intake. On the bottom of the intake, everything is smoothed out on that intake. So for example, looking at the stock intake, you have this indentation here because you have the screw tying the internal rod together. You have this indentation here as well. These indentations, they were made probably because this intake is made from plastic. Here you have a lot of internal sort of ridges inside, and these lower the volume of the total of the intake, whereas we found out that we don't need to have all of them in order for the intake to fit properly on the car. So we filled them in, we smoothed them out in order to enhance airflow, and here is the result. As you see, you don't have the indentation over here because you don't have the internal rods, you don't have the indentations here and here, and this part is a lot more smooth, and because it's smoother, that enhances airflow. That's the first thing. Also, it increases the internal volume of the intake. Now, the biggest advancement in functionality that we went for was the trumpets. And in my opinion, this is the biggest reason why we were able to gain horsepower basically everywhere. If you look at the OEM intake, what you're going to find is that it has these trumpets, which all of them are facing towards the throat of the intake. Inside, you're going to see all of these trumpets face that way. And the reason why we believe BMW designed it that way is because the air coming through here is able to reach all of them quasi-equally. The second reason why is structural rigidity of the plastic parts inside, and so by twisting them forwards, they were able to reinforce them. So they are twisted forwards, are attached not only at the bottom, but also at the curvature. Now, what we did with our Plenum is we decided to radically change that. So we looked at a lot of designs from the P65 airbox, which is the racing airbox from BMW. What we saw was a very different trumpet design. And so we started experimenting with trumpets and lengths and stuff like that. And what we came up with is a trumpet design where the trumpet is just like, you could call it a standard velocity stack. It squeezes the air gradually throughout the full length of the trumpet to the diameter of the throttle body. And that's another thing that the OEM design doesn't do. So the OEM intake, because the trumpets are plastic and they have been attached to the airbox by heating them up and attaching plastic to plastic through heat, they're not all centered. And so the diameter is a little bit bigger than the throttle body. So what we did is we matched the trumpet to the throttle body on our intake. That allows for a smoother airflow inside the head of the engine. Basically, less flow separation equals more power in this case. Also, we played with the lengths. We had about 5 different lengths that we tried out. And the design that we put into this intake enhanced power between 7 and 8,000 RPM, but we didn't expect to see an enhancement at the low end. We actually thought that the low end power is going to dip down. But actually what happened is at about 3,000 RPM, we gained about 25 Newton meters at the wheels. That was just a bonus, you know. Third thing I want to talk about is structural integrity. And this was a huge thing when we were designing this Plenum, because the client that approached us for this project is actually designing it for a race car. And so there cannot be any structural flaws. A lot of the intake creators on the market have had problems where the intake would basically start to bend in the middle under power. That is a problem. That shouldn't be a design choice. And there's one main reason for that. First of all, carbon fiber is one of the stiffest materials on the market. So you do not need a lot of layers of it to make a naturally aspirated engine not bend it. You know, you don't have these incredibly huge internal suction effects. It didn't even cross our minds to create an intake which would bend in the middle. A lot of people have said we wanted the intake to make more noise. We haven't seen through our experimentation any correlation between lack of structural rigidity and the amount of noise that the intake makes. However, the problem I was talking about is that even if the intake withstands those bends structurally, what happens is, especially on a DCT car, but even in manual cars, what would happen is, as the air is going into the engine and you're going into the high RPMs, the top part will start to vibrate and bend. And this vibration can create a resonance which starts to affect the suction properties of the intake. And so it could decrease them. It could start to create flutter so that the back cylinders are not able to get enough air. And not only that, but every time you decide to change gear, the intake will pop back into place. And that pop that's going to happen is going to suck all the air from the cylinder head back into the intake. It's going to create a reverse pressure in the opposite direction. And then you can feel a small jitter in the car every time you change a gear at high speed. For some people this might not be a problem, but in motorsport this could add up. It's not going to add up by a huge amount. On a race engine where everything is on solid bushings and the intake is having a lot of vibrations to deal with anyway, I don't think anybody would want for an unpredictable vibration an unpredictable power or air going into the rear cylinders, or some type of fluctuation in the power every time you change gear. This is why we focused on structure. And if you receive our intake, you can press the top of it. You will see that there is zero fluctuation in the item. It is extremely solid. One of the tests, funnily enough, was members of our team sitting on top of the lid of the intake. It never skipped a beat. It never bended. It never broke. This, we are certain, is one of the most structurally sound intakes on the market. Another thing we did is connected to the fixings. If you look at the standard intake, all of these fixings are parts of the structural body of the intake. On every carbon intake, you simply cannot make these out of carbon fiber. And so you cannot take the intake out of the mold with all of those fixings there to begin with. What we decided to do to create the best design, or what we believe is the best design when it comes to safety, what we did is putting nuts on all of those fixings so that they're physically locked to the carbon. Even the trumpets. Every trumpet, the ring at the bottom is basically a nut. And that nut is locking the item onto the carbon. Same thing with this. You have a custom-made nut, which is thread locked and is basically locking that part onto the construction. This is just for demonstration purposes. Again, this is a physical part which you can screw in and out of the intake. Same goes with the bottom part here. Same goes with the temperature sensor bung on the side. All of these parts are not only placed and used adhesive to bond them to the carbon, but they're also thread locked and have a custom-made nut which turns and locks them in place. And what this has allowed us to do is basically create an item which you know is safe. Most of the other items on the market, they are only bonded with adhesive. Yes, we do use adhesive on the inside. The adhesive is marine grade adhesive. It's also used for aviation purposes, so it's one of the highest quality, most expensive adhesives on the market. But we also make sure that there is a failsafe, and you have a nut and thread locker. Also doesn't allow for that nut to freely spin open or spin closed. And this gives you maximum amount of safety when it comes to this intake. You know, as much abuse as you can throw at the intake, it can take it. And that was a huge thing that we wanted to emphasize on, simply because it's important. At the end of the day, these cars, some of them are used for racing purposes or for track days. You know, this is something that we really focused on. So yeah, those are the differences between the Haimus racing intake and the standard one. If you decide that you want one of our intakes, just make sure you get in contact. If you like what we do, make sure to support us. Thank you very much.